Hello guys and welcome at my channel. Today I want to explain something about continuity. As you can see, I wrote already the definition of it. I hope you're familiar with it, but let me try to explain it maybe once again. So the thing is, if I have a continuous function at some point xo, I should be able to give you an epsilon value. This epsilon value is the boundary of the difference of the y values of the function. And you should be able to give me the corresponding delta, the length of the interval, so kind of distance from xo to point x, such that I'm never going to get over the epsilon value on the y-axis. So it's a kind of game we play. You give me epsilons, I find you x's, or vice versa, and they stick together. So let me give you an example of a maybe very easy function to handle. F of x equals to x. So let's say we are considering f of x minus f of xo, and this is by the definition x minus xo. So now look at this. X minus xo is the length of the interval, so it should be less than delta, and we are looking for the connection between delta and x. So x minus xo should be less than delta, and I can put a given epsilon equal to delta, and that's it. Why is that enough? Well, once again, what are we looking for? Well, you give me epsilon, I'll find you delta. So you give me epsilon, which is 0.5. I say, well, delta is 0.5 as well. That's it. I don't have to do anything else. This is the identity function, so that's why it's so easy. But let us maybe do it again with a slightly more complicated case, x squared, and then you'll see that it's a bit more tricky. So f of x equals to x squared. How do we start? Well, the same approach. We got x minus xo less than delta, and we would like to connect delta and epsilon. That's the story. If you wish, I can write a delta depending on epsilon. Maybe at the beginning it's nice to see it this way. So the story is we start with f of x minus f of xo, which is x squared minus xo squared. Well, we use the binomial formula right now. We write it down as x minus xo times x plus xo. And now we can split the absolute value into two absolute values in their product. So we got the product of x minus xo times x plus xo. And now, as you can see, this value x minus xo is already smaller than the given delta that we are looking for, but we want to connect it to epsilon. So this is smaller than delta. We don't know it yet. Don't forget, we're going to connect it to epsilon times x plus xo. So what's happening now? Now we're adding 0. That means we got delta times, now look at this, x. We are subtracting xo. I would like to have something like this in my equation. And then we add it up, so we add xo. And then we still have plus xo at the end. So that's the story. And now, using the triangular inequality, we can split it in the middle. So we're going to get less than delta times, now look at this, x minus xo plus 2xo. Well, since we are, well, I don't know, let's say x is bigger than 0. It doesn't matter actually, but I don't have to worry about the parentheses for xo. Well, it's not important. So the thing is, x minus xo is also less than delta. So this is less than delta times delta plus 2xo. And now look at this. All the values are set. Delta should be set. We're looking for this, but this is not variable now. XO is a point that we are looking checking the continuity with. So we set it equal to epsilon. So epsilon is equal to this value. And now what's important to understand, what we're looking for, we were looking for delta. So am I able now to find the delta value? Sure. I have to solve the quadratic equation. Are you normally asked at the university to do so? No, because it's already fine if you came that far. But I think it's important and crucial for the beginning to understand that you should be always asked to find delta as well. Only if you have delta in your hand, you got the proof. Okay, so look carefully at this, what I have to do here. I would have delta squared plus 2xo delta would be equal to epsilon. Now check it. delta squared plus 2xo delta equals to epsilon. I'll bring epsilon, and then I have to solve the quadratic equation, which is no big deal now. And then we'll have solutions for delta, and then we take the minimum value of this because we want to have the smallest interval, the smallest length of the interval. So let me quickly do it completely. Delta 1, 2 is equal to, you see, this is minus xo plus or minus square root out of xo squared plus epsilon. And now you see what we have. So this is, we said it's positive, so the negative case can be omitted. So we got delta equals to minus xo plus the square root out of xo squared plus epsilon. And that's it. I was able to find the delta value as well in this case. So all the continuity proofs run like this. So you start at the difference of the functions f of x minus f of xo, and you somehow try to manage the connection between the delta and the epsilon. And once again, I give you the epsilon, you're looking for delta, and you want to connect them. And the connection between those two, no x is allowed because x could be variable and you are not setting it. But xo and delta are perfectly fine. I hope you guys learned something. Stay at my channel. See you. Bye bye.